All right, continuing on with solving system of equations, but this time we're going to use a method called elimination. All right, so if we look at number 5, this is actually the same problem that we had in the last section. So with elimination, what you're supposed to do is you're going to multiply either this equation or that equation, it doesn't matter which one, by a number. Then when you add both of these linear equations together, one of these x's or y's are going to cancel out. So I'm going to go ahead and do it so you can see what I mean by this. So notice that on this, what I'm going to do is I want to cancel this 6. Right now, because I want to cancel this 6, I'm going to multiply this top part by negative 3. Right, again, I'm going to multiply everything on the top equation by negative 3. Alright, so I just rewrote that. And then what happens after that, you go ahead and distribute that negative 3, and you're going to distribute that across every single term, including this 7 right here. So this is going to be negative 21. And I'm just going to rewrite the second equation. All right, so if you look at it, it's not necessarily a problem. What ends up happening is this negative 6x plus 6x, that's 0. 3y minus 3y, that's 0. So you end up with a 0 on the left side equal to negative 7 on the right side. Now, remember what we talked about. It's kind of similar to what we talked about previously, which is when is 0 equal to negative 7? And the answer is never. All right, so 0 is never equal to negative 7. Therefore, this has no solution. Okay? And like we talked about previously, if you were to solve for y for each equation, you would see that you would have basically the same slope on both. All right? And if you have the same slope, that means you have two parallel lines, and two parallel lines will not intersect, and that's the reason you have no solution. Okay? So that was kind of a strange one to start with, but let's go on to number 6. On number 6, if you look at it, okay, if you look at it without me multiplying anything, if I add these two equations together, I would have 2y minus 2y, and the y's would cancel. So in this case, I'm going to go ahead and just add each equation as it is. So this is going to give me negative x. That's going to cancel, and that's what I want. All right. So the goal of doing elimination is for either the x or the y to be canceled out, so you can solve for the other variable. All right. So now I have negative x is equal to negative 2. And at this point, you're either going to multiply by negative 1 or divide by negative 1 on both sides. And when you do, you get x is equal to positive 2. All right. Now that you have this answer, all right, x is equal to 2, you're going to try to plug that into either this equation or that equation. It doesn't matter. It should give you the same y value. All right. So I'm going to pick the top one for no particular reason. So remember, if you're doing this right, even if I plug in a 2 here, you should get the same answer. All right, so we have 10 plus 2y is equal to 12, and then we're just going to solve for y. Now, obviously, I'm going to assume that you know how to solve a linear equation, but perhaps I expect too much out of you. I don't know. So remember, if y is 1, you're going to write the solution as a coordinate point. And remember that this right here is the point of intersection between those two lines. Okay? So it always helps to know graphically what's going on when you do this. Right? So again, the solution is the point of intersection between those two lines. All right, let's go to number 3. On this one right here, it's a good example because on this one, you have two linear equations. And remember what I said earlier, you want to multiply one of these equations, or sometimes both, times a number that would either eliminate x or y. Now in this case, I'm going to choose to eliminate the y's right here, right? But the problem becomes that there's not a whole number at least, that I can multiply this 2 to make it into a negative 3, and there's nothing I can multiply this 3 to make it a 2. All right? So when you found yourself in that predicament, what you're going to do here is you're going to multiply this by 3 and this by 2. And the reason you're doing that, notice if I multiply 3 times 2y, that's going to give me a 6y, and 2 times negative 3y is going to give me a negative 6y. So you should be able to see ahead and notice that that's going to cancel out. All right. So this is going to be 21x plus 6y is equal to negative 3. Notice that I'm distributing that 3 across all 3 terms. And then on the bottom I would have 8x minus 6y is equal to negative 26. All right. Now we're going to go ahead and add. We're going to go ahead and add those two linear equations, and your hope, if you did this right, if you're doing elimination correctly, one of the variables should cancel out. And in this case, the y's are going to cancel out. So now I have 29x is equal to negative 29, and I'm just going to solve for x. So x is equal to negative 1. And then now, what you're going to do from here is you're going to plug in this x value, this negative 1, into either one of those two equations. It doesn't matter which one you pick. Just pick one of those equations and plug in negative 1 for x. In this case, I'm going to choose to plug it into this top equation. And now I'm going to add 7 to both sides. I get 2y is equal to 6, so y is equal to 3, right? If you divide both sides by 2. So remember, one more time, you have to write your solution as a coordinate point, because what you just found was a point of intersection between two lines. So this right here is the solution. Alright, remember, if you wanted to check this, just plug in the x and y coordinate into both of these equations, and you should get them to work out. Alright. Now number 8, I'm not going to do it, but if you want to check to see if you did this right, the solution that I came up with was 6 comma negative 3. See if that's what you got. So try this one out on your own. And I hope this makes sense. Elimination happens to be kind of my favorite method to use for the linear equations. So make sure to ask questions tomorrow if you got them.